You ever wonder what really separates a good exam answer from a perfect one? Well, today we're basically going inside the mind of an AQA examiner. We're going to deconstruct a full 13-mark question, and we'll use the official mark scheme to show you exactly where every single point is won or lost. So, here's our game plan. We'll start by breaking down the question itself. Then we'll bank some easy marks by identifying the functional groups. After that, we'll get into the reactions, build a polymer from the ground up, and finally put it all together to see the whole marking picture. You ready? Let's dive in. All right, so question 8. It all revolves around this one molecule called compound A. And the whole question is designed to test your understanding of its structure and how it reacts, especially because of its two very different functional groups. Yeah, compound A is pretty cool because it's kind of got two personalities. It's an alkene and it's an ester. And that dual nature is the secret to unlocking every single mark in this question. To do that, we're going to use the official AQA mark scheme as our guide. And here's the thing. This isn't just about finding the right answer. It's about delivering the precise answer the examiner is literally looking for on their checklist. Okay, let's start with the first and honestly the most straightforward marks you can get. The question asks you to just identify the two functional groups, but you gotta be precise. First up, question 08.1 asks for the alkene functional group. As you can see from the mark scheme, all you need is a simple circle around that C double bond C. That's it. It's the perfect example of how just being neat and precise earns you points. 1 mark in the bag. Now for question 08.3, we're spotting the ester group. In this, right here is where a really common mistake happens. The mark scheme is super clear. You can't just circle the COO. Nope, you have to include both the COO and the CO single bond right next to it. That entire chunk is what gets you the mark. Okay, so we've identified the parts of the molecule. Now let's look at the reactions. This is where we get to show we understand how these functional groups actually behave. Right, question 08.2. This is a classic test for an alkene, shaking it with bromine water. For the 2 marks here, you need 2 points. First, the starting color is orange. Now, the mark scheme also lets you say yellow or brown, which is good to know. Second, the result is that it turns colorless. And notice that specific wording. You could also say it is decolorized, but, and this is important, if you write clear, you get nothing. The little details matter so much. Now for the heaviest hitter in the whole question, the balanced equation for complete combustion. This one's worth a hefty 3 marks. The correct answer is 2C4H6O2 plus 9O2 arrows 8CO2 plus 6H2O. But how are those 3 marks actually broken down? Let's take a closer look. This is such a great insight into how examiners actually mark things. You can get a mark here, even if your balancing is totally wrong. Just for writing the correct things on the left, that's C4H6O2 and O2, and the right things on the right, CO2 and H2O, you've already earned 1 point. The final 2 marks are for getting those balancing numbers correct. And don't waste time on state symbols. The mark scheme says they're ignored. Okay, we've gone from single molecules, now let's build some long chains. Let's tackle polymerization. Now, I know this topic can seem a bit intimidating, but once you see the logic in the mark scheme, it gets so much easier. In question 08.5, you're asked to draw the displayed formula for the repeating unit of polymer B. So what's the key thing that happens here? Well, that C double bond in the original monomer breaks open. That allows all the little molecules to join together, hand in a long repeating chain. So where are the 2 marks hiding? It's really specific. The first mark is for showing that the C equals C double bond has become a single C-C bond, forming the new backbone of the polymer. The second mark is just for drawing the brackets correctly around the unit and sticking that little letter N on the outside. That's it. 2 very specific checkboxes to tick. Question 08.6 is a nice, quick 1 marker. It asks for the type of polymer we've just made. Well, since the monomers just add together without losing any atoms along the way, it's known as an addition polymer. A simple definition for a simple mark. And then for question 08.7, we're told polymer B melts when it's heated, and we just have to give the word that describes this. The correct answer is thermosoftening. Oh, and the mark scheme also says thermoplastic is fine too. Either one of those gets you the point. Okay, our final question here, 08.8, flips it on its head. It asks why some polymers don't melt. And the secret is all in their structure. For the first mark, you have to mention that there are crosslinks between the polymer chains. For the second mark, you need to explain that these crosslinks are strong, and it just takes way too much energy to break them. So there we go. We have walked through every single part of the question. Now let's just step back, take a look at the whole picture, and see exactly how all 13 of those marks are spread out. And there you have it, the complete anatomy of a 13-mark question. As you can see, the marks are spread out all over the place, rewarding you for everything from just circling the right bit to writing out complex explanations. The big takeaway here is that every single mark is gettable when you know the rules of the game, and now you do. Look, at the end of the day, acing your exams isn't just about what you know. It's about how well you communicate that knowledge in the very specific way they want to see it. By thinking like an examiner and mastering the language of the mark scheme, you can take your answers from just good to flawless. So the real question is, are you ready to apply this level of precision to every other topic you revise?